we're going to keep on rolling with these example problems. The first one is this, so I don't know about you, I can't directly integrate this. So I'm going to have to go to step 2. So I'm going to select what's in the bottom. You could select it including the square root. I would not recommend you do that, but it is possible to do that. In fact, depending on how much board space we have left, I may try to do that, but I don't know if it's a good idea. All right, so what you do is you say u equals 6 minus x squared. So du is negative 2x dx. Or you could say dx equals du over negative 2x. So that's this piece and this piece. So we find the u, and then we take its derivative, and we get this piece, and now we're going to substitute in. So wherever I see 6 minus x squared, I get square root of u, and then I have an x, and then for dx I have du over negative 2x. So that means my x's will cancel, but I get a negative 1/2, or a negative 2 on bottom, so I get negative 1/2 1 over square root of u du, which I can then rewrite as negative 1/2 u to the negative 1/2 du. So then I use the power rule. I say negative 1/2 u to the 1/2 divided by 1/2 plus c, which is convenient because I have a 1/2 and a 1/2. The only thing left over is that negative. So that's negative u to the 1/2 plus c, which is negative square root of u plus c. So again, we were on step 5. I apologize. Step 5 goes from here to here. And then I finally have to replace u with the original expression, 6 minus x squared plus c. So that's how you do it. I may erase this one and show you how to do it the nasty way, but anyway. So for this one, directly integrating is technically possible here. You'd have to multiply this thing out. I just wouldn't recommend it. So instead, let's pick what's inside this parentheses as my u. So I'm going to say u is 3 plus 2 over t, which I can rewrite as 3 plus 2t to the negative 1. So then du, the 3 goes away. That becomes negative 2t to the negative 2 dt. But I don't like that, so I'm going to rewrite that as du equals negative 2 over t squared dt. And so then I'm going to rewrite this in terms of dt. I'm going to say dt equals negative t squared over 2 du. So that's how I'm going to do that. Now we're going to replace everything here. So this becomes, that's just u. So that's u cubed, 2 over t squared, negative t squared over 2 du. So those collapse except for that negative. So I end up with negative u cubed du. So at this point I've done step 4, and now I need to do step 5. So with the power rule, I add 1 to the power, divide by the new power. So that's negative 1/4 u to the 4th plus c. So again, I'm here, but I need to get back to my original thing. So it's not x, we actually started with t's, so I get negative 1/4 3 plus 2 over t to the 4th plus a constant. So that's how we do that. Now those are, I didn't circle it, or box around it, but that's there. But what I want to do, so I'm done with this, you can turn off this video here, but I want to do this one again with a second substitution. So I'm going to erase pretty much everything so that I have room to do this. So let's erase. And instead, let's use a different substitution. Let's kind of make our lives a little harder. Let's use the whole square root in this substitution. So that's the square root of 6 minus x squared, which then I can rewrite as 6 minus x squared to the 1/2. So then when I take its derivative, du, you bring down the power, subtract 1 from the power, and then multiply by the derivative of the inside, which is negative 2x. And then you get a dx here. So we can simplify this a little bit. Those 2's will cancel. And so I'm going to bring that negative out front. And then what I'm going to do is, when I have this negative 1/2 power, well, that's 1 over that. So I'm going to say du is negative x over 6 minus x squared to the 1/2 dx. But 6 minus x squared to the 1/2, that's a square root. So I end up with negative x over square root of 6 minus x squared dx. So then what I'm going to do is I'm going to take this negative, put it over there, because I just multiply both sides by negative 1. So that's just negative du, which is negative u plus c, which is negative square root of 6 minus x squared plus c. Which should be what I already got. I don't remember, I erased it. But that's another way to do it. But it's a lot more painful because the derivative you have to do requires the chain rule and all this other stuff. So in a lot of ways, you're setting yourself up with a lot more work on the front end, and you don't have a chance to check it early on. So I don't really recommend this method, but just know that it is available to you if you wanted to do it that way.